Okay, let's get things started off today. First off, let's see, before I get started, bing, bing, okay. Start things off today. Hello, my name is Lance Zurich, and I'm the product manager for the fischertechnik division over here at Studica. And today I'm going to provide you with an overview of fischertechnik robotics. So we're going to find out all about what fischertechnik robotics is all about. We're going to take a look both at the line of fischertechnik educational-based construction sets for exploring different aspects of robotics, things such as electro-pneumatics and IoT. And we're also going to look at the line of pre-assembled simulation models that are used for vocational training, CTE, things like of that nature, used in higher education and used for demonstrating various industrial processes. So, before we get started, the big question some people might have is, what is fischertechnik? Well, just to provide you with a brief introduction, fischertechnik is a flexible and innovative construction system. Now, unlike other popular construction sets designed to simply stack, the fischertechnik system was created with more of an engineering mindset. And what I mean by that is that essentially the core building block in the fischertechnik system is unique in that it allows attachment from all 6 sides. And because of this, it allows for almost limitless design possibilities. Now, many of the parts are designed to slide together and lock in place using a tongue and groove assembly method. And there are hundreds of different parts available, all of which will help you to address very specific design and engineering needs. Fischertechnik was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in the construction and automotive industries. Mr. Fischer, at the time of his death back in 2016, had amassed more patents in his name than Thomas Alva Edison had gathered during his own lifetime. Now, besides fischertechnik, Mr. Fischer was also the inventor of synchronized flash photography, and that was back in 1949. And he was also the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls, shelves, or what have you. I'm sure we've all used them at some point. His company, the Fischer Group, employs thousands of workers worldwide, producing many variations of fastening devices that are used in building construction. And they also produce numerous components used in automobile assembly, as well as providing consulting services in regards to various state-of-the-art manufacturing processes. I'd also like to point out that fischertechnik was the very first construction set among all the popular construction set manufacturers and brands to offer students the ability to build and program their own robots. And that was originally using the pre-Macintosh era Apple computers like you see on the screen now. Now, almost since its inception, fischertechnik has been used by middle schools, high schools, colleges, and universities all around the globe to explore STEM-related concepts. Of course, when we say STEM, we're talking about things like robotics, renewable energy, mechanics, pneumatics, and so on. Now, fischertechnik has also been used by numerous companies, including companies like Porsche, Daimler Chrysler, and BMW, just to name drop a few, for industrial simulation and training purposes. Now, recently, we've also seen many of the top companies at the cutting edge of developing IoT applications, of course, the Internet of Things, or cloud control, as we'll sometimes refer to it, using these same simulation and training models to demonstrate and study various IoT-related processes. Now, with all this in mind, more than just being something that students would only use for a year or two in their development, you can really think of fischertechnik as being designed so that students can grow along with it. Essentially, as students progress through their academic careers, they could also progress through the various levels of fischertechnik education solutions, which are available. Fischertechnik education products are designed essentially to offer a progression. At the elementary level, specifically grades 2 through 5, there are curriculum-based options for introducing brief, achievable projects based around the areas of simple machines and introductory robotics and coding into classroom activities. Now, at the middle and high school level, fischertechnik offers sets for performing various STEM-related activities around a progression of subject-specific models focused on areas such as renewable energy, pneumatics, physics, and of course, robotics. Fischertechnik also has more comprehensive, standards-focused curriculum sets offering a complete and fully integrated project-based STEM experience as a class unto itself. And for college classes focused on robotics and automation, or for vocational and technical schools, there are also the series of pre-assembled industrial simulation and training models, which I touched on before. Now, while the subject matter may become more advanced or sophisticated as you move through the progression, the same building system and the same parts are used throughout all levels. Now on your screen, you're going to see a list of the various product lines that fall under the banner of Fischer-Technic Education in order of how they appear in this progression I just mentioned. Again, for the purposes of this presentation, we will focus on the two areas you now see highlighted in red, that being the line of robotics-focused construction sets and the line of pre-assembled simulation and training models. That being said, let's begin our exploration of the Fischer-Technic Education robotics line. Now on your screen, you see a list of the products in the line. This slide shows, in bold-faced red, the 7 construction sets found in the robotics line. Each of these sets either focuses on a specific area of robotics, and this would be such as robotics in industry, or on a particular age range, such as the Minibot set, which is intended for younger students. And each of these includes instructions for building a specific progression of models related to that area. Now, please note that these sets, while all educational in nature, do not contain formatted curriculum, but instead, each of these sets contains either printed teaching and activity materials, or it will provide access to downloadable versions of such materials. Now, the materials designed to provide teachers with suggestions for various experiments and tasks that students can perform with each finished model in class. The two items I didn't highlight previously are the controller and the software, which are used with many of the Fischer-Technic robotics sets. The Fischer-Technic's Robotics TXT controller, shown here in red, is the interface or control unit for all the upper-level robotic sets. And the RoboPro software, also shown in red, is the graphic programming software used for all Fischer-Technic robotics. These two items will be required for many of the sets that I'm going to discuss today, as well as either a Fischer-Technic AccuSet or a power set, all of which are available for individual purchase. Now, in a few cases, some or all of these items are included in the sets, but as we proceed through the presentation, I will, of course, let you know specifically where such items are required for use with the sets or where they're already included in the sets, just so if you're taking notes, you'll know what you need to get. Now, going back to the robotics sets themselves. Each of these sets are designed so that they can be used in a middle or high school setting, but there's no reason that they cannot be used in a college class as well when exploring these topics. Each set comes packed in a sturdy plastic Ratno storage box, and each includes a printed full-color, step-by-step assembly manual for building all of the models, as well as additional teaching and activity materials, again, either in a printed format inside the box or else available for download from the Fischer-Technic e-learning portal. Also, as a rule of thumb, unless otherwise noted, we would suggest that each of these sets be used by no more than 2 students at a time. This, of course, to keep everyone actively engaged in the process of whether it be programming, building, whatever might be required. But obviously, you want to keep everybody actively participating as opposed to people just watching. Now, the first set in the Fischer-Technic's robotics line is the Minibot set. And this set includes 145 parts for building 5 different mobile robots. The set provides an engaging pathway for introducing students age 8 and up to the world of robotics. Now, the models are all powered by an everyday 9-volt battery, and while the battery isn't included inside the set, everything else you need is. No PC is required with this set. Now, the models in this set utilize a specialized pre-programmed robotics module. Students can select from different programs on the module by using a series of 5 sliding switches, also known as a DIP switch. Each switch is either placed in an up or a down position to select from the various programs that are programmed into the module. Now, one of these options will enable students to create a short motion program of their own by using 2 buttons and the Teach-In mobile robot. Students begin by learning about actuators, a component, of course, that performs some types of action, such as the included excess motor. And they also learn about sensors, which do not perform an action, but instead react to situations and events such as, for example, a push-button switch or the infrared trail sensor. The first model students will build is a basic mobile robot. Students can control the speed and the direction of the robot by using a potentiometer located on the robotic control module. Next, students will build a hindrance or obstacle detector. Now this robot is constructed with 2 of the mini push button switches acting as sensors. When this robot bumps into an obstacle it encounters in its path, it will back up and deviate from the path of the obstacle. And again, the direction of this deviation can be controlled through the use of the potentiometer. The third model is a trail sensor, which combines some of the attributes of the previous models with an infrared trail sensor. Now, this enables the robot to follow a trail in the form of a black line. Now, students can both use the trail found on the pre-printed obstacle course included inside of each set, or they could use a magic marker to create their own black line path of at least 20 millimeters wide for the robot to follow. The fourth model combines the hindrance detector with the trail sensor. With this variation, the trail sensor reacts to a black line it encounters not as a pathway, but instead as if it was an obstacle to avoid. The fifth and final model allows students to build a teach-in robot. Teach-in is a concept from the world of robotics where a robot is moved to a series of desired positions, which each are saved inside the program so that then the same movements can be repeated easily in the future. Now, students will learn how to run this teach-in created program either on a one-time basis or, if they wish, in an endless loop. And that's essentially a look at the Robotics Minibot set. As you'll see, pricing starts at $142 for a single set, and of course, classroom pricing is available by quote upon request. Now, the next set in the Fischertechnik's robotics line is the Robotics BT Beginner set. And the BT in the name in this case refers to the ability to control the models via Bluetooth. The set contains 380 parts, and it allows you to build 12 real-world style models and offers an ideal introduction to instrumentation and control for students age 8 and above. Students start off with an overview of the components they're going to be working with. Now, as with the previous set which we discussed, they begin by learning about actuators, in this case, such as the LED module and the XS motor, before moving on to a brief overview of the sensors found in this set, specifically push button switches and the phototransistor. Students then learn about the type of circuits that can be made with the push button switch. Next, students are provided with an overview of the BT Smart Controller. They learn about the 4 inputs for connecting the sensors, 2 outputs for connecting actuators, power connections for either a 9-volt power adapter or a 9-volt battery, and the ability to connect to the computer or tablet hosting the programming software either using a USB or Bluetooth 4.0 connection. System requirements for this controller are either a computer using Windows 7, 8, or 10, or an Android tablet or smartphone equipped with Android 5.0 or higher. Now, selected Bluetooth 4.0 sticks are also required by Windows 7 machines. The BT controller, by the way, is also compatible with Scratch. Users are walked through the various methods of Bluetooth connection, as well as the installation of either the RoboPro LT programming software for a PC or the RoboPro Smart app for Android devices. Next up, students are given an overview of the RoboPro LT software. They learn about the logic symbols or elements used to create their control programs, as well as the layout of the program's work environment, which includes the toolbar, the work screen, the test window, and so on. Students begin to explore the actual programming by working with the first model, that of a merry-go-round simulation. Now, using this model, students learn the basics of working with graphical programming software. They learn what a control program is, they learn how elements are added to a program and connected to one another, and they learn about adding time delays and modifying actions, such as, in this case, the direction of rotation. They learn how a program is designed to start and stop, how it can be looped, and how a program can be expanded. Students explore further variables in programming with the building and control of a pedestrian light simulation. Here, students work with various settings such as the sequence of phases and the brightness of traffic lights. The next model, that of a lighthouse with a blinking light, allows students to explore the programming to address the 3 principles of lighthouse lighting. Students first learn about the isophase principle, And this is where the beacon is programmed so that the length of the light and dark phases are of equal duration. They learn about the flash principle, where the light phase duration is programmed to be only a fraction of the duration of the dark phase, and the blink principle, where the two lights on the beacon are programmed to be illuminated for a different period of time, independent of each other. The refrigerator door simulation offers further programming challenges. Here, students will be first asked to program the light to go on when the door is open, and then will be asked to modify this program to cause a red indicator light to start flashing when the door remains open for a specified period of time. The next simulation students build is a drum-style washing machine model. Here, students will work with programming different cycles with variations in time, in speed, direction of rotation, and programming a safety switch for the door, as well as also programming a text display to show the current cycle. The next model to be addressed is an automated hand dryer, which is programmed so that when a light barrier is broken, a fan switches on and remains on until the light barrier is no longer interrupted. The exploration of the use of light barriers continues with the construction and programming of a parking barrier that raises to allow vehicles to pass when the light beam is broken. Students will next build a trio of industrial simulation models. The first model of a punching machine requires students to program a safety switch, and this is where the machine will only operate when two switches are held down simultaneously, along with the light barrier. The second of the industrial models to be addressed is a conveyor belt. Students program the belt to activate when the first of two light barriers is interrupted or broken, and to switch off when the second light barrier is breached. And the final industrial simulation combines the functions of the previous two models. Now, in this case, students will program the conveyor belt with a punching machine to move a workpiece down the belt to be punched, and then reverse direction and move the workpiece back to the starting position. The final two models with this set introduce students to mobile robotics. First, students will build a tracked vehicle. Here, students will be required to program the motors that move the tracks on each side of the robot to run at different speeds so that the vehicle will move in various directions. Students program various direction changes with different motion times. The final model adds a hindrance or obstacle detector to the tracked vehicle. Students are asked to build some simple obstacle courses out of materials they may have on hand, and then to program the robot to recognize and drive around these obstacles. The instructional material also includes a special section specifically on programming and controlling the various models using the downloadable RoboPro Smart app on Android-based smartphones and tablets, as well as the Bluetooth feature. And that essentially is the Robotics BT beginner set. Once again, 380 pieces in all, including the BT Smart controller and the RoboPro Lite software for building 12 models. And as you see, pricing starts at $225 per set, and classroom pricing is, of course, available. We will next step up to the main tier of the fischertechnik robotics line, and this will be with the Robotics TXT Advanced set. This set contains 310 parts in all, and that includes the Robotics TXT controller, full color touchscreen controller you see over there with some of the attributes of the controller, and a license of the full RoboPro programming software. Once again, this all comes packed in a sturdy plastic Gratnell storage box. And regarding the TXT controller, as you see, it is the most advanced controller yet created for fischertechnik robotic models. It boasts a full-color 2.4-inch touchscreen display, a combined wireless Bluetooth module, a micro SD card slot for additional memory space, an IR receiver diode, an integrated loudspeaker, 4 motor outputs, 8 digital analog inputs, 4 sensors, and 4 high-speed numerical inputs. The TXT controller has 128 megabytes of RAM, 64 megabytes of flash memory, and a 600 megahertz processor. And as I mentioned earlier in this presentation, the Robotics TXT controller may also be purchased separately as you wish, and it has its own part number if you're so inclined. The RoboPro software is the full version of the programming software that is used for all the advanced fischertechnik robotics models. So this is not the same as what we just looked at in the previous set. This is the full RoboPro. And it also is used for all the 9-volt versions of the industrial simulation models that we're going to look at later in this presentation. Now, RoboPro is essentially graphic programming software, which uses easily identifiable icons in a flowchart style design to make programming easy to understand, even for the most unfamiliar student. Now, it should also be mentioned that the software includes sample programs for all of the models that will be built with this set. So everybody will have a starting place, and then you'll learn how to modify it. Now, with the aid of the RoboPro software, it is also possible to program your own apps for controlling the models with your Android, smartphone, tablet, or PC. Now, students can visit the manufacturer's website for more information on this, as well as the fischertechnik e-learning portal, using the access code included in the assembly instructions. RoboPro software is also available for purchase separately in both single-user licenses, or if you wish, in unlimited school site licenses. Excuse me. Now, the contents of this set, with the addition of a fischertechnik AccuSet for powering the models, which is required and which is sold separately, the contents of this set will allow students to build 14 realistic models, including mobile robots and also robots incorporating vision systems. Now, the latter is made possible with the addition of the fischertechnik USB camera attachment, which is also included in the set, and you see it right up there. Once again, students will start off by learning about the different components that will be used in constructing their robots. They first, once again, learn about actuators, which of course are the components that perform some type of action. And examples of the actuators found in this set include the encoder motors, the excess motor, the LEDs, and the lens tip lamp. Next, students will examine the sensors that are going to be used. And the sensors, again, of course, act as the counterpart to the actuators. This is because, once again, they do not perform any actions, but instead react to certain situations and events. And examples found in this set include the phototransistor or the light sensor, the push-button touch switches, an NTC resistor, which is also known as a heat sensor, and the previously mentioned camera module. Students will first progress through the building and experimenting with a series of starter models to become familiar with the TXT controller and the software. And these models will include a simple ventilating fan, a timed pedestrian light simulation, a hand dryer equipped with a light barrier, a temperature control where once the specified temperature value is exceeded, the fan is turned on, and an automated barrier, once again using a light beam that must be interrupted for the barrier arm to raise. After this, students will begin to explore the use of the camera and image processing with the robotics. The first model of the cameraman introduces students to how they can view what the robotic camera sees on their own computers using, of course, the RoboPro software. They will also turn the cameraman into a motion detector. And in the process, they will learn how intense a motion must be to actuate the sensor and how extensive the motion must be in relation to the entire sensor field for the robot to react with a flashing alarm. They're going to work further on this idea with the next model, which is that of a swiveling security camera, where a motion can be made to trigger an alarm which will sound through the loudspeaker of the TXT controller. Students begin to explore the area of mobile robotics by first building a basic mobile robot. They learn about how turns and changes in direction can be programmed. They will also learn how the use of standard motors will often only yield imprecise results, and how greater precision and movement can be achieved with the use of the encoder motors. With encoder motors, the rotation of the motor is measured with the use of a magnet and a sensor, much as a bike speedometer clocks the revolutions of the bike wheel. Next, students will build or create a mobile obstacle or hindrance detector. The robot will be programmed to back away from obstacles it may encounter, move around them, and resume on its journey. Students will modify this model with the addition of the USB camera module to create a robot that can react to color and also share what it sees as it moves about in the world. And with the use of a wireless connection between the TXT controller and the PC, Students will also be able to control the robot remotely. The next model that students will build and experiment with is a trail searcher that uses the camera to detect and follow the path. This can allow for even greater precision in reacting to changes ahead, such as curves in the pathway. The detection robot combines several camera functions in one model. The robot is able to look forward to detect its surroundings. It is also able to look down to follow one of the various colored trails on an obstacle course, such as the printed one that is included with the set. And the robot also uses the NTC resistor to collect temperature data. Students can also download the TXT Camdroid application from the Google Play Store. And this app allows them to connect the TXT controller to the Android smartphone via a wireless connection, enabling them to remotely control the detection robot. For the final exercises, students will build two variations of a soccer playing robot. The first variation includes movement control, where the camera is mounted on a stand next to the robot, and the robot is taught various tricks, such as, for example, how to shoot a ball once it is detected by the light barrier, or how to react to movements made in front of the camera. For the second and final variation, the camera module is installed directly on the soccer playing robot. And this robot uses a printed simulation or stadium simulation, which is also included in the box. Students then go about various programming tasks to enable the robot to properly detect the ball and various markings of the stadium. By recognizing these markings, the robot is then able to properly position itself on the playing field with a higher degree of accuracy. All 14 of the models which we just discussed can be built with the Robotics TXT Advanced set, which once again includes both the Robotics TXT controller and the RoboPro software. As mentioned previously, a fischertechnik AccuSet, which is sold separately, will also be required to provide power for all of these models. Again, pricing on this set starts at $540 per set. And of course, if you need classroom quotes, also with the additional AccuSet, you can contact us and we'll be happy to do so. The next two sets that we're going to review each contain parts for building specific types of robotic models and are essentially designed as add-ons to the Robotics Advanced TXT set, which we just looked at. Now, each of these add-on sets will require users, again, to have a Robotics TXT controller, will require that you already have the RoboPro software and either the AccuSet, which I've mentioned a few times, or a fischertechnik power set to help add power for the models. Now, the first of these two sets that we're going to look at, these add-on sets, is the Robotics and Electro-pneumatics set. And this set contains 440 components, which, when combined with the items I just mentioned, will allow you to build 4 different electro-pneumatic machines and robots. The instructional material that accompanies this set begins with an overview of the principles behind pneumatics, which is known as the science of producing motion with air. Students will learn how a pneumatic cylinder works, how pressure is calculated, and the process of generating and storing compressed air with the use of a compressor. Students then learn about using valves, and this would include solenoid valves to control the flow of air to the pneumatic cylinders, so the cylinder either expands or retracts. They also learn about how electrical and pneumatic circuits can interact. The first model addressed in the progression is a compressed air motor, which acts in a manner similar to a steam engine, except that in this case, instead of steam serving as the propellant, it is compressed air. Students then experiment with different methods of controlling the model. For example, manual control with the use of a push button, and also incorporating a switching plate for continuous motion. Next, the model is wired to the Robotics TXT controller so that students can then explore how a program can be used to control the model. The second model they're going to build is a simulation of a color sorting machine, and this is such as you might commonly find in an industrial setting. Now, this model incorporates a vacuum suction device used for gripping workpieces and to move them about. And it also incorporates an optical color sensor, which is used to sort the various parts by measuring the reflected light from each piece, which is output as a specific voltage between 0 volts and 10 volts. Students learn that each color is assigned its own approximate voltage, and how the sensor helps the machine to sort the parts by where each piece falls in this voltage range that's set up. So students learn how these color values are defined. Students learn about the various sensors and actuators introduced in this model, which includes the use of a phototransistor and a lens tip lamp, which are used together to form a light barrier. They also learn about the electric motor and the vacuum pump, as well as how the control program and color recognition subprogram required for this model are created in RoboPro. The next model of a ball obstacle course utilizes a vacuum picker arm to automatically return balls to the starting position. Now, the importance of accuracy of construction and attention to detail when wiring are stressed. Students perform further work with subprograms and learn about defining variables in a program. The final project in this set, the building of a pinball machine simulation, pulls together all the elements touched upon previously into one fun and very sophisticated model. And that is the robotics and electro-pneumatics set. Once again, this set will require a few other items or the TXT advanced set first. Pricing on it starts at $240 per set. Classroom pricing is, of course, available upon request. The second of the two add-on sets is the robotics in industry set, which, like the previous set, allows you to build 4 different models, but this time, of course, focuses on simulations of the type of robots that you would most likely encounter in an industrial setting. The set itself contains 510 pieces, and this includes aluminum struts for greater stability of construction of the robots you're going to be working with. The teaching and activity PDF that accompanies this set begins with a brief overview of industrial robots, their origin, and the many areas of production where such robots are used, which would include things like welding, cutting, measuring, grinding, stacking, assembling, and so on and so forth. Now, as in the previously discussed sets, an overview of the materials that will be used is provided, and this, of course, again includes the actuators, the sensors, the controller, and the RoboPro software. The first model to be built with this set and worked with is a gripper robot, which is designed to be able to raise and lower its arm and also to be able to turn. Robotic positioning is discussed, as well as specifying the position of the linear and rotary axis of the robot. Students are asked to create a reference run program and a flow chart. They will then revise portions of the program. The second model to be addressed is a high bay storage rack, as is found in many modern warehouse systems. Now, as the positioning needs with this model become more sophisticated than the models we have discussed before, more subtasks are required, each of which requires a subroutine to be created in the robot's program. The third model addressed is a pivoting gripper robot, which allows you to create a robotic arm which can position work pieces at a different angle than they were originally picked up at. Now, once again, further positioning subroutines must be created by the students for this new pivoting action, which building on the programming steps that they've learned about in the previous model. So this puts a little bit more of a twist on things. The final model is that of a 3-axis industrial robot with a robotic gripper, which can move in 3 different directions. Now, while the previous 3 models built were designed for very specific activities, the 3-axis robot is, by contrast, more of a multifunction robot, which can be used to perform various types of work. With the 3-axis robot, students work with the teach-in method used for for programming industrial robots. Now, once again, the teach-in method is where the program is, the teach-in method is where the robot is moved to specific positions using the controller, and the position is learned, or saved in this case, and then moved to the next position, which is also saved, and so on and so forth until you have the full program. Now, the sequence of saved positions together will comprise a program consisting of all the various motions which the robot can later perform by itself. Students will create their own teach-in program using this robot, so that's something they get to do there. Students also learn about French mathematician Edouard Lucas and the puzzle he invented in 1883 called Towers of Hanoi. and this puzzle involves the moving of plates, or in this case, work pieces, in a specific arrangement. Students then use the 3-axis robot to help solve this puzzle. And that essentially is the robotics and industry set. Again, like the robotics and electro-pneumatics set we looked at before, you will be required to have a TXT controller, RoboPro software, and either the fischertechnik AccuSet or Power Set to use all of the models. Pricing on this subset starts at $270 per set. Of course, classroom pricing is available upon request. Whoop, jumped ahead. The next set in our progression is the Robotic Sensor Station IoT, which is available in 2 versions, either as a complete set, which includes everything you need. That means the controller, the software, the power supply, everything you need in one box. Or there's a version that, like the robotics and industry and robotics and electro-pneumatics set, where as long as you already have a controller, you have the software, you have the power supply, all you need is to buy the subset. Now, the focus of this set, or sets in this case, is to provide students with an introduction to data logging, as well as cloud-based control, what we might refer to as the smart home and the Internet of Things, which is also, of course, known as IoT. Now, the downloadable teaching materials designed for this set begin with an explanation of some of the key terms being encountered here. Digitization is discussed first, beginning with the roots of the term, which actually date back to the original computing machines created by Gottfried Leibniz back in the 17th century. Now, essentially, the term originally referred primarily to the conversion of analog data into zeros and ones. Now, the more modern use of this term refers to the storage and processing of data without using paper. And this would be things like such as the conversion of printed books into ebooks, or of music saved as MP3 files. Now, the term Internet of Things refers to the global networking of real and/or virtual objects using computers located around the world, which allows these real or virtual objects to exchange information with one another. The term smart home, also known sometimes as efficient living, refers to the networking of household appliances and things such as heating systems, lamps, washing machines, and so on, where they can be monitored and controlled from a central point. Finally, the term Industry 4.0 is also discussed, which is somewhat similar to the idea of the smart home. But in this case, the process of producing a specialized good that meets a customer's particular criteria can be completely automated, even up to the point of preparing these goods for actual shipment. Now, in cases such as this, the first actual human to physically interact with these goods might well be the person involved in delivering them to the end user. Now, after this, we get into a discussion of some of the components included and the suggested work habits, similar to how these topics were addressed in the previous sets that we've reviewed here already. The first activities will center around a simple model of a light with a brightness sensor. The idea here is that such a light could be used outdoors and the light itself controlled depending on the level of ambient brightness. Now, this is a great activity for enabling students to become familiar with using the robotics TXT controller, as it is designed to take students step by step through the act of creating a program for the model using the RoboPro programming software. First, students are going to need to create a program for the robot where it will be, as it becomes darker, the light turns on. Now, doing this will require students to experiment to determine a threshold value, which in this case is a resistance value to be registered by the phototransistor, which in turn causes the light to go on, or instead to turn off when a lower value is registered. Now, once students have created a successful version of the program utilizing these resistance values, they will then be asked to create a program where the 3 different lights on the model will switch on, one after another, as it becomes increasingly darker, until all 3 bulbs are illuminated when it is completely dark. The next model built will be of a noise sensor. In this case, students will utilize a sensor that is already built into the circuit board of the included USB camera attachment. With this model, students will be required to create a program that continuously measures the noise level, such as different decibel levels, and as different decibel levels are reached, different indicator lights, and this will be either in green, yellow, or red, will need to be illuminated on the model. Designing the program will require students to utilize a subroutine. The next model will replace the USB attachment with an environmental sensor, which is an all-new fischertechnik component that's unique to this set. And in this case, they're going to create a robotic wellness sensor. The new environmental sensor will enable the robotic model to be able to measure such variables as gas, atmospheric pressure, humidity, and air temperature. In this case, students will incorporate a special block in their programming containing both an init and a get block. 3 different programming projects will be addressed with this model. The first project involves the creation of a frost monitor. Here, the ambient temperature is to be continuously monitored. If the temperature falls below the value of 3 degrees Celsius, a red warning lamp is to come on and an alarm from the TXT controller will need to sound once. In the second programming project, the model will be used as a mold monitor, where humidity is continuously measured. Here, the red warning light must be illuminated when the humidity is 80% or higher, indicating a danger of mold forming. In the third programming project, students will use the model as an air quality station. And in this variation, students will need to program the model so that the lights are illuminated differently to indicate different levels of air quality from very good to bad. Next up, students will work with a model of a stationary camera that includes an environmental sensor for data logging. The first project will involve programming the model to act as a motion sensor security camera, which causes an acoustic and visual alarm. And in this case, that would be the sound from the TXT controller combined with the lighting of a lamp to be triggered when a motion is registered. The second exercise involves an introduction to simple data logging. Here, the values registered by the built-in brightness sensor are to be displayed graphically on an oscilloscope monitor, which can be viewed in RoboPro. The third exercise with this model will involve logging the values collected in a spreadsheet program, where the data can then be displayed using, for example, a beam diagram. A fourth exercise will essentially combine the last 2 exercises, in this case, where the data is both displayed on the oscilloscope in RoboPro, and at the same time the values are saved in a CSV file for graphical display in a spreadsheet. The fifth and final experiment with this model involves a flower vase with soil and a seed being placed in front of the camera. Students must then create a program to measure the temperature, humidity, atmospheric pressure, air quality, and brightness. The values are to be measured every 12 hours and saved in a CSV file, and each day a photo must also be taken to provide further visual information on the growth of the seed. Next, students will construct a robotic barometer and program it so that the pointer on the model will point to a weather symbol, such as in this case, sun, clouds, rain, so forth and so on, corresponding to the current atmospheric pressure, depending upon the atmospheric pressure measured. The final model students will build with this set is a complete sensor station with a movable camera. This model will utilize various forms of data transmission connection via USB cable, access point connection using wireless via Wi-Fi connection, which is the computer, the TXT controller, and Wi-Fi client connection from the computer to a router to the TXT controller. The first programming project will involve using the model as a rotating surveillance camera with the results viewable on a computer using the RoboPro software. Students will then learn how to connect the TXT controller to a PC using Wi-Fi. And after this, they will learn how a Wi-Fi client connection can provide a greater range than a simple connection directly to the computer, depending, of course, upon the power of the particular internet router being used. The second project is an expansion of the first, where not only is the camera controlled, but the environmental data being collected is also displayed on the oscilloscope. And as soon as the camera registers motion, an alarm is sounded. The next programming project involves learning how to connect the sensor station model to the cloud for the collected data to be displayed there. A special fischertechnik managed website is accessed, where a dashboard monitor can display the various types of data collected from the environmental sensor, as well as the visuals from the camera. Students also learn how to control the camera itself from the dashboard monitor on this cloud-based site. Students see how they can control the model from anywhere around the globe with a smartphone, a tablet, or any PC with access to the fischertechnik cloud via the internet. And that is the Robotics Sensor Station IoT set. Once again, the set comes in two different versions. The first version, which you see is part number 544625, like the previous two sets we discussed, would require that you supply your own RoboPro software, a Robotics TXT controller, and either the fischertechnik, AccuSet, or PowerSet in order to build all the models. But the second version of this set, 944937, would include everything you need to build the models you've just seen right in one box. So if you weren't doing things with other fischertechnik models, this would be the way to go. If you had other things, then you could go with the first set. The next set is the starter set for Microbit, which is designed for teaching the basic principles of programming with Microbit single board computers to students in grades 3 and above. The set includes a selection of 90 parts for building 3 stationary automated models, along with the new fischertechnik Microbit I/O F5 adapter board with 8 outputs and 6 inputs. Now, please note that the Microbit controller itself, as well as the required control software and power supply, are not included here and will need to be obtained separately. The teaching activity material for this set, which is downloadable from the fischertechnik e-learning portal, starts off with a brief overview of the Microbit controller itself, the I/O F5 adapter board, and the MakeCode software, which students will use to program and control the various models. Students are told how to unpack the Microbit, how to access the MakeCode software using a web browser, and how to perform a functional test of the Microbit with the MakeCode software to ensure that everything is working properly. Students are also walked through a download of a program to the Microbit, how the programming is saved, and they learn that the file type must also be a hex file. Next up, the materials discuss using the editor in the program. Students learn how the MakeCode screen is divided into 3 sections: simulation, programming commands, and the programming screen. They also learn about the other important buttons found on the screen, such as the Start/Stop button for the simulator, the Download button, the Save Project button, and the Undo, the Zoom In, Zoom Out features. Students also learn how to load partial or finished projects from storage media, how to import files, and how to browse for files. Blocks and commands are also discussed. Each single command, as with the individual blue lines you see on the screen now, are grouped into blocks based upon their function. Now, in the example shown here, the 5 individual commands are grouped under the block called LED, shown in the column on the left. Next, the students learn about the first automated system they will build a simulation of, which in this case is a traffic signal with a button that can be pushed by a pedestrian. Now, the parameters of this system are discussed, such as, for example, what lights would be illuminated, the duration of the light, and so on. Students then build their own version of this pedestrian signal, with a request button. Now, following the completion of this model, students are given a programming task where the system must be powered by a button on the Microbit acting as a service switch. The light, which should normally be red, is only to switch to green when a requested button on the traffic light mast is pushed. The students are given a duration for the green phase of the lighting, and they're also given other parameters, and they must begin then to create their program using the commands in MakeCode. Now, along the way, they are also taught about actuators, which in this case would include things like the push button switch and the sensors, like the LED light. And after the completion of the initial exercise, they will also modify the program to make the light flash. The next simulation model students are asked to build and program is a hand dryer with a light barrier. Now, they will initially need to design a program where a user reaches through the light barrier to activate the motor with the propeller to start up. And when the same hand is removed, the motor stops. Here, students will incorporate the phototransistor and the motor into the new model. Students also learn about digital and analog values and more about the different types of blocks used in the programming, such as basic blocks, pins, inputs, logic blocks, and so on. After this programming exercise, another program designed to make use of the LED display that is part of the Microbit is also addressed. The final exercises are designed around the third model, which is of a parking garage barrier with an arm that raises or lowers. Now, the programming work in the initial variation of this model and a variation incorporating an optical display will be much more extensive than what students had encountered previously. And in this case, it's going to incorporate subprograms and loops. And that's the starter set for Microbit. Once again, the Microbit, the software, and the power supply are not included. And that completes the overview of the Fischertechnik's robotics line. Next, we're going to move on to the Fischertechnik Industrial Simulation and Training Model line. Now, the line of industrial simulation and training models differs from the other Fischertechnik products because they are not sets consisting of parts where the end user needs to build something, but in this case, they are instead pre-assembled models mounted on a wooden base. These are really designed for use in colleges and universities, or also for training in companies and, of course, vocational schools. Now, besides this, they are also widely used by many companies for exploring and demonstrating IoT, for product and software development, for logistics and production planning, and for understanding automated systems. Each model in the current line of simulation and training models is available in two different versions. There are 9-volt versions, which are most commonly used in an academic setting. Now, these models come pre-wired to Fischertechnik Robotics TXT controllers. And I should add that these controllers have also been pre-programmed using the Fischertechnik RoboPro software. Now, with the addition of a basic 9-volt power adapter, such as the Fischertechnik Power Set or another power adapter of your choice, these models are essentially ready to use right out of the box. Unpack them, connect them to the TXT controller and to a power supply, turn it on, and hit the start button. Now, there's also downloadable activity material with more information on the components, which can be accessed from the Fischertechnik e-learning portal. Now, there are also 24-volt versions of each of these models, which would be much more commonly used in industry or for higher level technical and vocational training. Now, these contain 24-volt versions of components, such as the encoder motors would be a 24-volt version, the S motors, the compressors, the lamps, the solenoid valves, and so on. Now, these models, these 24-volt models, will also require a standard industrial PLC, which is, of course, a programmable logic controller. And this would be such as the ones manufactured by companies like Siemens, Allen Bradley, Hitachi, Mitsubishi, and so on. So you're going to need the PLC for all the control. And also, because there is no programming supplied with these versions. So the creation of all the programming needed for the 24-volt version will be the responsibility of the end user. And as with the 9-volt versions, there are also downloadable activity materials that can be found on the Fischertechnik e-learning portal. Now we're going to begin with a look at the 5 newest models in the simulation and training line. The first is the vacuum gripper robot, and its part number, as you see up there, 536625, is a 9-volt version, which is wired to a pre-programmed Fischertechnik's Robotics TXT controller. And then there is part number 536630, which is the 24-volt version designed for use with PLC. And this model is essentially a 3-axis robot with a vacuum gripper, which can quickly and precisely position workpieces in 3-dimensional space. The next model is the automated high bay warehouse, available in both the 9-volt version, once again pre-wired to the TXT controller, which is pre-programmed. Just need the power supply with that. And there is also another version, 536631, which is 24-volt, requires PLC and programming. And this model essentially acts as a simulation of a storage system similar to what you would find in many modern warehouses. It has a transfer station with a conveyor belt and a shelf stacker for storing and retrieving special workpiece carriers from the 9 storage bins. Next is the multi-processing station with an oven, once again available in both the 9-volt version, but in this case, this version is wired to 2 Robotics TXT controllers, although you still only need 1 power supply. And then there's also, again, the 24-volt version, which will require a PLC and programming. And this model is designed to simulate a furnace with a pneumatic sliding door. The downstream processing station with the pneumatic transfer unit includes a vacuum gripper, a cutter simulation, a rotary table, and a conveyor belt. Now after this, we have the sorting line with color detection. As you see, once again, a 9-volt version, pre-wired to 1 Robotics TXT controller, and then also part number 536633, which is the 24-volt version requiring your PLC and programming. And this unit is designed to detect work pieces of different colors and to sort them using a conveyor belt into the designated storage slot. Now, the final of these 5 models is the factory simulation, which essentially integrates the previous models, the vacuum gripper, the high bay warehouse, the multi-processing station with oven, and the sorting line with color detection into one self-contained material cycle. Now, as you'll see, part number 536629 is the 9-volt version, which in this case is wired to 5 Robotics TXT controllers, and it will require 3 separate power supplies to power it. Part number 536634 is the 24-volt version, again for use with industrial PLC. I will mention that since we've created this webinar, there are 2 new versions, which are basically an enhancement of what we're looking at right now, which is called the Training Factory Industry 4.0, and it's essentially a cloud-controlled version of what you see here with some added little substations. So if you're looking for something like that, I would suggest that you visit our other webinar focused on simulation and training models. We'll give you a nice overview of that. Now, the other 4 models that are currently available are the older classic models in the simulation line. There's a 3D robot, which is again available in both 9-volt and 24-volt versions. And this is a 3-axis robot with gripping forceps used to quickly and precisely position work pieces in 3-dimensional space. As you'll see, this is essentially a version of the robot that came with the Robotics and Industry set that we looked at earlier, but it's pre-assembled and in some cases pre-programmed. The conveyor belt is a simple transport belt, in this case 275 millimeters in length, used for transporting work pieces with a diameter of up to 29 millimeters. Now, these conveyor belts can easily be connected to one another if necessary. And once again, this is available in both a 9-volt and a 24-volt version. There's a punching machine with conveyor belt, which, like the name says, simulates the movement and punching of work pieces. And the next model is the index line with 2 machining stations. And this is a conveyor line with both a milling station and a drilling station simulation, and 4 conveyor belts in a U-shaped arrangement. Now, once again, this is available in both the 9-volt version, pre-wired in this case to 2 Robotics TXT controllers, and the 24-volt version with an industrial PLC. And actually, we did have this in here. The next version is the brand new release that this came out in last summer originally, the 9-volt version. We just had a 24-volt version come out this year. And this is the Training Factory Industry 4.0 model. And as you see here, that's, like I said, this is made for cloud control. This model connects to a dashboard where you can have 3 different views of the situation. You can see the person who's going to be ordering product, they have a certain viewpoint. The people who are managing the factory have a certain viewpoint. And then there is also something for ordering more raw materials. So there's 3 different views on this that are available. And this model is designed with the focus for use in higher education as well as in industry, where solutions are needed for realistically demonstrating how automated processes can be monitored and controlled remotely. Now, among the unique features of this model are a Wi-Fi router, a calibration station, an environmental sensor for tracking environmental related data, a USB camera for remote visual monitoring, an NFC chip, an NFC reader embedded in workpieces so the exact location of the work cycle can be monitored, and the fischertechnik maintained cloud, complete with a dashboard where, again, all the various processes can be monitored and controlled. Now, the dashboard, which can be accessed and operated via mobile devices such as tablets and smartphones, as well as, of course, by laptops and PCs, enables platforms to be viewed from 3 different perspectives. Again, a customer view, a supplier view, and a production view. And essentially, that's a quick look at the Training Factory 4.0. As I said, since we've created this, I actually forgot that I was including this in this presentation. But since this was created, there is also a 24-volt version. If you do visit our other webinar, we will also show you a video of that as well. And I will also mention that we also offer special custom aluminum storage and travel cases for any of the factory simulation models, either the 9-volt and 24-volt regular factory or the Training Factory Industry 4.0. Those are available from us as well for $1,000 a piece. And that's essentially the simulation and training line. Now, before we conclude things today, I do want to touch very briefly on 2 more sets, each which is covered in their own webinar. Now, the reason each has a webinar is that each of these sets comes with extensive and highly detailed standards-based curriculum, which is essentially for offering a standalone robotics or STEM class, or a long-term after-school activity if you want to look at it that way. Now, that being said, while each set is designed for conducting a curriculum-based program, they also really serve as great all-in-one bundles of some of the most popular fischertechnik robotics sets, with everything you need to build a large group of models. And this is from the parts to the controller, the software, the power supply. In these cases, everything you need is going to be right in the box or downloadable. Now, the first of these 2 sets is the fischertechnik's robotics competition set. And this is a curriculum-based set designed to provide a pathway for exploring the subjects of robotics and coding through the focus on having students create mobile robotics of the type which could be used in a competition setting, whether at the local school level, or even if you want to get involved with larger scale national and international competitions, things like the RoboCup Junior, for example. The set itself is designed around standards-based curriculum consisting of approximately 70+ academic hours of teaching material. Now, each of these sets contains 670 parts components, all packaged like the other sets we've discussed today in a sturdy Gratnell storage box. And when using the curriculum, the set is designed for use by small teams of students of 2 to 4 students per set. So it's easily scalable. So if you think of, depending on what your parameters are, if you want to use this with 3 students per set, you have 15 students in your classroom, you need 5 sets. So it's all very easily scalable. And essentially, this set is designed around, and as I said, again, if you'd like to know more about the specifics of what this set addresses, I invite you, of course, to attend the webinar, which goes over all of this in detail. But for right now, what I want you to consider is the fact that this can be thought of as the ultimate fischertechnik mobile robotics set. Now, this one set will provide all the materials needed to build the models in both the fischertechnik's Robotics TXT Advanced set, which we looked at earlier, as well as a retail set called the Robotics Explorer set, focusing only on mobile robots. And it also, of course, includes everything else you need: the Robotics TXT controller, the RoboPro software, the AccuSet for powering the models, and what have you. Now, with this set, 20 different models in all can be built with it. And again, everything you need is right in the box, and it's very affordable, starting at just $699 per set. And of course, classroom pricing is available upon request. Now, the last set we're going to look at today is the fischertechnik STEM engineering set, the contents of which you see on your screen right now. The curriculum for this set is designed to provide a comprehensive overview of robotics, coding, and automation systems. In short, what we like to refer to as mechatronics. Now, like the previous set, it's designed to be used by groups of 2 to 4 students in a classroom setting. This set contains 890 parts in all, including, of course, again, the RoboPro software, the Robotics TXT controller, and the AccuSet, all of which again come packaged in a sturdy plastic Ratinol storage box. The standards-based curriculum, which is targeted at a high school level class, has a series of project theme units covering the areas of sketching and documentation, basic electricity, programming, sensing and vision systems, mobile robotics, actuators, and the fundamentals of automation and robotics. Now, the curriculum for this set is designed to provide enough academic material to cover over 150 academic hours. So essentially, this provides teachers with enough material to offer a standard 50-minute class period focused on STEM and robotics 5 days a week for a full academic year. Again, if you'd like to know more about this set, the standards address, the way that the material itself is approached, and so on, I of course invite you to attend our webinar focused on project-based learning. For today, what I'd like you to take away is that this one set, besides having the curriculum I just mentioned, also contains all of the parts and all the instructions needed to build all 22 models from 3 sets that we reviewed earlier: the Robotics TXT Advanced set, the Robotics and Electro-pneumatics set, and the Robotics and Industry set. And once again, this can be thought of as a great all-in-one option for obtaining everything you need in one box at a special price, even if you chose not to use the curriculum for whatever reason. So we've covered a ton of material here, and I'd really like to thank each and every one of you for your patience and attention and for sticking with us this far. Now, as promised, I'm going to open up the floor for questions. So if you do have any questions, again, please either use the question and answer window on the Zoom toolbar or the chat window. I will give you 1. I will give you 2. I don't see any questions coming through, but I will mention that if you do have any questions, if you'd like to speak with any of us directly, if you'd like to speak to your dedicated educational representative, or if you'd like to speak to me about any aspects of what we've talked about or looked at today, or any aspect of Fischer Technic, you can call us directly. Our number in the US is 888-561-7521. You can also visit us and see all these products online at www.studica.com/fischertechnik, FISCHERTECHNIK-education. You can email us at info@studica.com, or you can email me directly, lance.zurek, that's lance.zurek@studica.com. So on that note, I'd like to thank you all very much for attending. Have a great day, stay safe, and we look forward to hearing from you soon.